All right, so here at Getting Ready 30, we're working all with inequalities. So the first set of questions here already have the line graphed in the appropriate spot on the coordinate plane. All we have to do is decide whether we are going to shade above or below that line. So the method that they suggest we use here is to pick a point. It can be any point in the graph that is not on the line. To determine which half plane should be shaded. Okay, so once we choose that point, we're going to substitute it into the x and y for our inequality, and it's either going to give us a true or a false statement. If it's true, we shade the half of the plane containing that point. If it's false, it means that point should not work, then we shade the opposite side. Okay, now I always try to use the point 0, 0 whenever possible, just because it's the easiest one to plug in. I can always use that unless the line happens to go through the origin, 0, 0. In that case, just pick some other easy point, 1, 1 or 2, 2, 1, 0. So if I want to look at this one, I can go ahead and use 0, 0. It's not on the line, so I'm trying 0, 0. It would look like this. I take my inequality as it's given to me. You always want to put it into the original problem. If you have moved or rearranged or solved for a certain variable, don't use that one because you might have made a mistake. So I put 0 for y, and I also put 0 for x, and I see what happens. So the left side remains 0, is less than or equal to, now 1/5 times 0 is 0, and 0 minus 4 is negative 4. So 0 is less than or equal to negative 4. Well, that's false. So what that means is this point 0, 0 does not work. If 0, 0 doesn't work, then nothing over here on that side works either. That tells me that I should shade the opposite direction. So I would shade everything below the line. Okay. Number 2, I can use 0, 0 once again because the line does not pass through the origin. So when I replace y with 0 and replace x with 0, and when I multiply by 0, this entire term just goes away. So I'm really left with 0 greater than or equal to 5. Well, is 0 greater than 5? No. So that's another one that's false. So 0, 0 did not work. That means nothing below the line here works. And I will shade everything above the line. Number 3. Again, I can use 0, 0. The line does not go through the origin, so I'm going to continue to use that. 5 times 0 minus 2 times 0 less than or equal to 10. 0 minus 0 less than or equal to 10. So is 0 less than or equal to 10? Yes, that's true. So what that tells me, since 0, 0 worked, everything on that side of the line, in this case above the line, all of these points will also work. So I shade everything on the side containing the 0, 0, the point that I tried. Number 4, I get to use 0, 0 still, because the line is not passing through the origin. So 3 times 0 plus 4 times 0 greater than or equal to 24. So 0 plus another 0, so this whole side is 0 greater than or equal to 24. Well, that's false. 0 is not larger or equal to 24. So that means 0, 0 doesn't work. So nothing down here works. Only the other side of the line. Okay, so at number 5, we're working backwards. We have the complete graph. We have the line in the right place. We have the appropriate side shaded. So we are going to have to write the inequality that is represented by the graph we're looking at. Now, we know even if the directions did not say inequality, it must be an inequality whenever there is shading. Okay, that doesn't happen with an equation. So inequality every time you see shading. So what we need to do is identify 2 points on this line so that we can make the slope-intercept form of the equation. So there's a point, I can see 0, 7, and I see a point here, 7, 0. It doesn't matter which 2 points you pick, just choose any 2. So to determine slope of that line from the 2 points, I can either count rise over run, which is probably the easiest method, or I can use the formula y2 minus y1 over x2 minus x1. I'm going to do it both ways just to refresh your memory. So if I'm going to count rise over run, I pick either point as a starting place, and then how many boxes, how many units do I rise? 1, 2, 3, 4, 5, 6, 7. How many do I need to run? Well, I'm going left, so it's going to be negative, but I go 1, 2, 3, 4, 5, 6, 7. So I rise positive 7, I run negative 7. 7 over negative 7 is negative 1. So that's my slope. Had you decided to use the formula instead, y2 minus y1 divided by x2 minus x1, which is just a more specific way to write delta y over delta x, the y values go from 7 to 0, so 7 minus 0, and the x values go from 0 to 7, 0 minus 7. So 7 over negative 7, again, is negative 1. Now, if you counted the opposite order from what I showed you, or if you put them in the formula in the opposite order, you would have just gotten the negative 7 on top and the positive 7 on the bottom. Negative 7 over positive 7. That's still negative 1. That's also a correct method. All right, so I have my slope. In this case, I can see the y-intercept. In fact, it was one of the points I identified. So I don't have to solve for that, but sometimes you will. Okay, sometimes it hits at 7.3, and you can't tell that from looking at a graph. You have to solve for the b term. So the equation of the line is y equals negative 1x plus 7. But that's the equation just of the line, the purple line there. We have to change that equal sign to an inequality symbol in order to get the shading. Well, since the shading is below the line, it has to be less than, and that is only true when your inequality is in slope-intercept form, but that is how we're writing it. So we want y is less than negative 1x or negative x plus 7. And our last decision is it less than or is it less than or equal to? And you decide that based on whether the line is solid or dashed. Since this is a solid line, meaning all the points on the line count, we want the equal sign under there. So y is less than or equal to negative x plus 7. Okay, same procedure. So number 6, I need to choose 2 points. Again, just like last time, I can actually see both intercepts, x and y intercepts, so I'm going to use those. This is 0, negative 4. This one is 2, 0. You don't have to use intercepts, but I like them when I can see them. So if I count rise over run, I rise 1, 2, 3, 4. I run 1, 2. So 4 divided by 2 is 2. My slope, my m, is 2. I can see, again, the y-intercept. So the equation of the line is y equals 2x minus 4. And we're left just deciding, are we shading above or below? So y is, since it's shaded above the line, we say y is greater than 2x minus 4. And since the line is solid, equal to. Number 7. The 2 points, I can see the y-intercept is 0, 10, and the x-intercept is negative 5, 0. So my rise over run, I'm going to rise 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So rise over run, I went up 10. I'm going to the right 1, 2, 3, 4, 5. 10 over 5 is 2. So the equation of the line is y equals 2x plus 10. It's shaded below that line, so I'm going to write my inequality as y is less than 2x plus 10. And since the line is solid, we include or equal to. Now, number 8 is just a horizontal line. So we can go through that same procedure that we've been doing, although this one actually, when we're done, it should have been much easier than that. Okay, so if I choose 2 points again, it doesn't have an x-intercept, so I can use my y-intercept, which is 0, 3. And then I can pick another point, say 5, 3. Now, if I'm trying to do rise over run, from one point to the next, it doesn't rise at all. So that's 0 over, and it can run, well, that will change based on which 2 points you picked. Mine runs 5. But regardless of which 2 points you picked, you should have a 0 in the numerator, which means my slope is 0. So y is equal to 0x, and then the y-intercept is 3, that's plus 3. Well, you could write that, but you'll get made fun of by we math nerds. So you don't need to include this 0x. It's not doing anything. You don't have any x's. And the equation of that line is really just y equals 3. So maybe you remember then that any horizontal line, it has a slope of 0, and an equation just y equals a constant. So this one is shaded below that horizontal line, so y is less than 3. Since the line is solid, we need to include or equal to. Okay, number 9. Now we're graphing from start to finish on our own. Okay, so we're given this equation, this inequality in slope-intercept form. That does make things a bit simpler and a little bit shorter, because we already know where the slope and the intercept are. That'll get us 2 points to make the line. And only when it is in slope-intercept form, y alone, we can trust this inequality symbol to tell us which way to shade. Okay? That is not true if you are not in slope-intercept form. In those cases, you do need to do that test point like we did on the first couple questions. So in slope-intercept form here, my slope is 3. We want to think of it as a fraction, so 3 over 1. And my y-intercept is negative 4. So start at the y-intercept negative 4, and then rise 3 and run 1. You can do that again, rise another 3, run another 1. Another 3 over 1. Enough, it only takes 2 points, but again, depending on your neatness, you may want to do that rise over run a couple of times. So my line passes through those points. It should be a solid line because it is less than or equal to. And again, I can only trust this because I'm in slope-intercept form, but the less than sign tells me I should shade everything below the line. Okay. Number 10, also in slope-intercept form. Again, that makes everything much, much simpler. So slope is the coefficient of the x term, so it's negative 2, and as a fraction, that's negative 2 over 1. My y-intercept is positive 3. So begin at your y-intercept 3, and since my slope is negative 2 over 1, I can either rise negative 2 and run 1, -2, 1, -2, 1. Or I could have considered this to be 2 over -1. They're both the same simplified answer of -2, which would tell me rise 2 and go 1 left. Rise 2 and go 1 left. All right. Your line should be solid because it has the or equal to. And because it is less than, we can shade beneath the line, underneath. Number 11, also in slope-intercept form. We're really getting away with some easy ones here. The slope is 4 over 1. The y-intercept is -3. So first point should be the y-intercept -3. Then I will rise 1, 2, 3, 4, run 1. Rise 1, 2, 3, 4, run 1. Place my line, which once again should be a solid line because it's greater than or equal to. And this time it's greater than or equal to, so I will be shading above the line. All right, and last one, number 12. It looks at first like it's in standard form. I guess it is in standard form, but there is not a y variable anywhere in the inequality. Okay, it's not 3x plus 4y, and that's not a typo. We do just want to graph this inequality that has one and only one variable. Well, I don't like the way it looks now. I could simplify this so that all my constants were on one side. I would want to subtract 4 on both sides. So 3x, that remains less than or equal to 8. Okay. Divide both sides by 3. X is less than or equal to, now you do not want to round that. That would change. You don't want 2.6 or 2.7. You keep it 8/3 or 2 2/3. Okay. So how do I graph the line that only has an x in it? I can't think of it, I can't put it into slope-intercept form. Well, that's because there is no slope of a line that has only an x. Those are vertical lines. So if having only a y gives you a horizontal line, I hope it makes sense to you that having only an x gives you a vertical line. So I go find where x is equal to 8/3, right? So I'm pretending this is an equal sign. 8/3 is 2 2/3, so 1, 2, and 2/3. And then I want a vertical line through that value. Now the reason that this is a vertical line when we have only an x is think of this equation as a rule, telling me that the only thing that matters about all of these infinitely many points is that the x coordinate is 8/3. So here's 8/3 0, here's 8/3 1, here's 8/3 2, here's 8/3 -1, 8/3 -2, and so on. All of the points on that orange line, what they have in common is the x coordinate is 8/3. Okay. Now, in this case, our less than or equal tells us, to shade. We normally say below the line, but in this case, below is to the left. So everything to the left of that line gets shaded. It is a solid line because the inequality symbol does have the little equal bar under it.